Hello and welcome to another video. In this one, we're talking about typing star-args and star-kwargs. So I guess both of them. I have previously covered this in a video, but back when I covered it in that video, there was some tech that wasn't available. So I'm going to show you the new ways to do this, as well as I guess the old way and like how it works in general. I also covered this in the Python 3.11 release notes video and the Python 3.12 release notes videos. So I guess if you want to check those out, search my channel for that. You know, the easiest way is to go to YouTube and search. Why is it so slow? Anthony writes, wow, it's just recommending my entire playlist. Perfect. I guess that makes sense. You know, Python 3.11 or whatever, and you can watch this video where I talk about some of the stuff we're going to cover in this video. Okay, but anyway, let's start with making a virtual env and installing a what the heck? Virtual env. There we go. What was that thing that tab completed? That was weird. We're gonna start by installing a type checker just so that we have a type checker. We're using MyPy 1.20.1 in this video. Presumably it will work with newer versions, but okay. So when we're talking about star-args, I'm talking about both the single star-args, so the ones that collect all positional arguments, and I'm talking about star-kwargs, which collect all named arguments. And so we're gonna cover both of these and talk about the ways to type both of them and go from there. All right, so the first, I guess, and most important base case of typing these is to just have a normal type here. So if we have like stir or int, this signals to the type checker that every single one of the arguments that appears in these objects or is passed as arguments in these must be of that type. So this is saying that every positional argument must be a stir and every uncollected name argument must be a int. You obviously could have other arguments here as well. So like, you know, a named only argument foo could be a stir. That's possible here. We're just talking about the ones that are collected by these stars here. And so in this case, if we called f with an integer here and ran the type checker on it, you'll see that it's complaining that it must be a stir, even if, like, you know, some of the arguments were stirs. You know, it'll now complain that argument 2 is the incorrect type. In the same way that if we called g with a named argument that was an integer, it's going to be okay with this. But if we call it with, you know, some other named argument that is not an integer, the type checker is going to complain that we passed in a string there. I forgot to fill up my water. Oh well, this is a non-slurp video. And so this is kind of the base case of typing these, but this isn't that interesting. Typically, you know, you might want to represent your positional arguments as some you know, variable structure here, like maybe it always has to start with a string and then it has integers after it or something like that. Like you may want something more interesting than just stir here. And in the same way, you might want your keyword arguments to be some sort of structured type, like maybe you're passing them along to some other function that has a explicit list of arguments, and you just want this as an easy way to pass them along, but you still want the type checker to help you out here. And that's where the second part of this comes in, which is unpacking into these arguments. Now, unfortunately, in my opinion, the work that was done in Python 3.12 was a little bit incomplete. And so I'm going to show you what's incomplete about star-kwargs first. And this might change in the future. There's kind of the promise that eventually the syntax will be better. But for now, we're going to use kind of the gross version of this. And that is this thing called unpack. In Python 3.11, this was added, and in Python 3.12, it started supporting star-kwargs. If you need before Python 3.11, you can import it from typing extensions, but you'll have to pip install that. Typing extensions. Oh, behind my head. Oh well, whatever. But yeah, if you need the backport, it's there. We're not going to be using the backport in this. We're just going to be using the most modern syntax at the time of recording this video, with the hopes that in the future this may be improved. All right, so let's talk about star-kwargs first, because I think that is the worst one because we are forced to use this unpack. You can use unpack with star-args, and I'll show you that when we get to it, but there's a nicer syntax using actual unpacking, which is great. But I think the star-kwargs support was maybe a little bit rushed in the PEP, and so they didn't have time to do the syntax change as well, and they just haven't circled back to it. I assume they will at some point, but I don't know. Anyway, so what you can do with this is you can unpack a typed dict into this star-kwargs from typing import typed dict. And this allows you to define a structure for these star-kwargs instead of just like, you know, defaulting to boring any and just allowing anything to come in here, or being forced to make these homogeneous and requiring a single type here. What unpack and type dict allow you to do together is structure these kwargs. So if we make a type dict, I instinctively started to write name tuple. It shows you this shows you what types of classes that I make most of the time. So let's say that we have, I don't know, x as an int, a as a stir, and y as a, I don't know, bool or none, something like this. I don't know, completely arbitrary arguments here. But now you can annotate this star-kwargs using unpack and the type dict typed here. And what this now means is that this star-kwargs must have, well, actually, in this case, these are all required arguments because they don't have any defaults here. And so, actually, how does this work? I forget how this works. I think you have to say that they're required, and these are in the not necessarily required mode. Like you would have to say, well, you know what, we'll just try it and find out. I'm pretty sure right now you can call this without any arguments because these are neither required nor optional. They're kind of in the default state. I am not correct here. They're by default required. You can make them optional by using not required. I think that's what it's called. Let's see, do we get only 2 errors now? Yeah. So you can say, like, in this case, x is not a required parameter here, but a must be a stir and y must be a bool or none. And so now this is a valid call to this function here. And you can see here, if we pass something of the wrong argument type, so let's say we passed x as an integer, or a string instead of an integer, you'll see here that MyPy is able to detect that we've passed the wrong type here. So this is pretty powerful, especially if you have like a bunch of functions that take the same type of arguments and they don't actually need to play with them internally. You can use a type dict intermediary with star-kwargs, and then, you know, say you actually call into like return G implementation with star-kwargs. Like this allows you to do, you know, some amount of work and then pass the arguments along without actually caring about you know, enumerating all these arguments over and over and over. Now, it is a little bit annoying. Like in this case, you would probably also have a function that's G impl that has a as stir, y as bool or none, and then x as an int with some default. I don't know, something like this. So you would still kind of have this annoying case where you have a type dict here and you have to still enumerate all these arguments here, which is a little bit annoying. Like you kind of have these two things in the same place. I started writing a library or a MyPy plugin that seems like a good idea here. Did I finish the type dict part? Yeah, I did. So I made type dict from func. This is a MyPy plugin. I wouldn't necessarily use this yet. I don't know that it's production ready because I haven't tried to actually use this this library yet. But in theory, this allows you to not have to deal with the duplicating of the parameters here. But shameless plug here. So I don't know. Maybe try this out, see if it works. I was pretty happy with at least the demo that I was able to make working with this. So. Might be of interest. Anyway, this is the unpack syntax. I believe in the future, and this is not in Python yet, but probably will change in the future. You'll probably be able to do something like this, but for now there isn't something for that. So this doesn't work. You have to use the ugly unpack version of this. Okay, so that's star-kwargs. Let's talk about star-args next. I'm actually just going to get rid of all this code here because that will make it easier. Actually, we'll keep unpack because we might need it. Okay, so it's star-args. It's very similar to star-kwargs in that we are going to do, a special unpacking into this here, but it turns out we can actually just use the star operator directly. Obviously, you can't use the star operator if you are earlier than Python 3.11, because I believe that's when this syntax was added. In that case, you have to use unpack instead of this. And so let's talk about what this means right here, what I've written here. This is saying that star-args must be exactly 2 arguments long. The first one must be stir and the second one must be int. Now this seems a little nonsense. Like, why would you write something like this? I'll talk about that in a second, but let's just show it works. And if we put another argument here, it's going to complain too many arguments. So why might you do this? So I have seen one use case for this. And I don't think that it's necessarily a particularly good one, but there is a concept in Python called a positional only argument, which might be able to be written like this: stir y int. Yeah, this same function here, where this is sort of an equivalent syntax. Well, actually, these both would have to be positional only to be equivalent. This would be equivalent syntax to this here, but this is supported in versions of Python that don't have positional only syntax. Personally, I don't like positional only arguments. I feel like this is kind of a wart of the language that was shimmied in to make the C code look a little bit more normal, but this is kind of a backport way to do positional only arguments. Let's talk about another use case that I think is slightly less obtuse, or slightly more powerful than just like a fixed number of arguments here, which is that you can have a variable number of arguments here. So you can splat in a tuple that is variable. Of course, this is silly. There's no reason to write something like this because it is the same as just back to what we had before. These are equivalent. But you can do something kind of powerful here, which is you can have a tuple of a different type and then splat the tuple into that. So this now says that the first argument must be stir, and then there's any variable number of integer arguments afterwards. And we're just using the star operator on a tuple here to kind of combine these tuples. You can also use this just for tuple types in general. It doesn't have to be for arguments. So you can use this as a type other places to represent a tuple that starts with a stir and then has any number of integers after it. This wasn't possible in the typing syntax until Python 3.11. So this is kind of like a pretty powerful extension here. And of course, if you're not using Python 3.11, anytime you see a star, you can wrap this whole thing in unpack, which makes this look a lot uglier if you have to. Like, now we have 4 brackets here. We have to figure out exactly where those all line up. But if you need the support in older versions, that's how you would do this here. Okay, so now looking at this example here, this function call is actually already okay. But if we had passed, I don't know, none here, MyPy is going to hopefully tell us that like we expected an integer in that variable argument segment there, but we did not find one. Also, in this variable segment here, this means 0 or many. So if we had left out the integers here, this is still technically allowed. If you wanted to require at least 1 integer, you could put it into the base tuple here, and now it's going to say we don't have enough arguments until we add an integer there. So just kind of a neat little set of tricks there. And that's typing of star-args and star-kwargs. It's basically, if you just use normal types, it must be completely uniform. Otherwise, you can use these unpackings to have more structured types here, or more variable length types, or heterogeneous types here. And I did want to mention one other thing, which is a common mistake that people make here, which is that, and this is not how it works. I'm telling you a mistake that people make. I see very often people put star-args and then tuple stir ... expecting that, like, when you're dealing with args inside the function, it is actually going to be a tuple. And so the expectation is like, oh yeah, this must be all stirs, and so they've typed this as tuple stir stir stir. But actually, if you were to reveal type, oh my goodness, reveal type on args, you would actually have tuple of tuple stir ... which is not what you expect here. Well, not what the author intended, because this is actually saying that every positional argument is a variable length tuple, instead of saying the arguments in whole are a variable length tuple of stir. So easy mistake to make here. I see this more often with kwargs instead, where people will put dict stir any as this, because kwargs will end up being a dictionary at the end of the day, and the keys will always be strings. But what they really intended to write was instead just any here. So quick little pitfall, don't do that. Where possible, type things using the unpack syntax, and type dicts for your star-kwargs is kind of nice, so you don't make mistakes on passing arguments along. And I don't know, maybe check out typing derive. I haven't worked on it in a while because the thing I had a use case for, I no longer work there, so anyway, hopefully you found this useful. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.